Hello YouTube fam, welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will use pre-trained YOLO models to do object detection and human posture detection. We will do object detection and pose detection using YOLO and Ultralytics. YOLO, which stands for You Only Look Once, is a state-of-the-art real-time object detection system. Unlike systems that process an image at the level of individual regions, YOLO looks at the whole image in a single pass, hence the name. It divides the image into a grid, and for each grid cell, it predicts bounding boxes and probabilities for each box. These boxes are then filtered based on the probabilities and a threshold value to give the final object detection output, with each box having a class label assigned to it. This approach allows YOLO to be fast and efficient, suitable for real-time applications. YOLO is like a super-fast robot that can look at a picture and immediately point out and name all the different things it sees, like cars, dogs, or bicycles. Instead of looking at tiny parts of the picture one by one, it sees the whole picture all at once and quickly figures out what's in it. It's like playing I Spy with my little eye super quickly. Ultralytics is a company that specializes in artificial intelligence and machine learning, focusing particularly on vision AI, which involves teaching computers to understand and interpret visual information from the world. They provide advanced AI solutions, offer services related to project development in the field of computer vision, and are known for their work on the YOLO, You Only Look Once object detection model, which is used widely in various industries for real-time object recognition. Previously, we have done a video about posture detection. Please refer to those videos and notebooks regarding how to calculate angle between the vectors and determine if the posture is good or if it needs to improve. To start with, we will install libraries like Ultralytics and OpenCV. We can do object detection using Ultralytics in just a few lines of code. First, we will load the pre-trained model YOLO V8N. We then run inference by calling the model function by passing the image in which we want to detect objects in. Results 0, show, will display the image and objects detected. It will display the confidence level as well. We can see it detected person and laptop in our sample image. The show function will open a new window. It will not display in the Jupyter Notebook. Just for illustration, we have pasted the result image. Next, we will do pose and landmark detection. First, we will load the pre-trained model YOLO VN pose. We then run inference by calling the model function by passing the image in which we want to detect poses in. Show will display landmarks and will draw a line between the landmarks. We can see it has detected eyes, shoulder, elbow, hip, knee, ankle, etc. It can detect 17 landmarks. Alright, now we will see how to not use the inbuilt show function and have more control over displaying the landmarks. We will extract the key points from the result and then we will use OpenCV to draw the landmarks. If we look carefully at the output of key points, we can see that there is a component called XY, which shows the X and Y coordinates. We will loop through the landmarks, get the X and Y coordinates, and draw a circle. We can see we have drawn green circles on different landmarks like eyes, shoulder, elbow, knee, ankle, etc. Furthermore, we will find and plot specific landmarks like shoulder and hip. Ultralytics has provided the labels for the model's outputs. We will store them in an array called labels. When we access the key points, we can use the index position of the label we desire to find the coordinates for that landmark. For example, in the labels array, nose is at index 0, left shoulder is at index 5, left hip is at index 11. If we want to get the nose landmarks, we will get the key points XY component at index 0. To get the left shoulder landmarks, we will get the key points XY component at index 5. We will use OpenCV to draw circles. We can see we have drawn green circles on different landmarks like shoulder and hip. Now that we have the coordinates of different landmarks, we can find angles between landmarks. We will find the angle from the x-axis. First, we calculate differences in coordinates. Then we calculate the angle using arctan2, which returns the angle in radians. Then we convert the angle from radians to degrees. Please refer our previous video on human posture detection using MediaPipe, where you can find the code sample to find the angle. Using the angle, we can determine if the posture is good or if it needs to improve. Finally, we will look at how to do object and pose detection in videos. We can use it for videos in MP4 files or in live video camera frames. For each frame, we will get the prediction from the YOLO VN pose model. For the first use case, we will use show equals true, which will display all the key points as it is. Here is a sample output displaying key point results as it is. We can see it detected a person and shows key point landmarks like eyes, shoulder, elbow, wrist, and so on. Detected. For the second use case, we will use show equal false, which will not display all the key points. We will then add custom logic to add some text like number of persons. We will add custom logic to display which key points have been detected. We will output the resulting frame using OpenCV. We can see that the output has texts like shoulder detected and ankle not detected. So that is it, friends. We used pre-trained YOLO models to do object detection and human posture detection. Get ready for an exciting round of trivia delight. Let's dive into some fascinating facts. Could you kindly take a moment to decode these acronyms and share your insights in the comments below? Your contribution would be immensely appreciated. 1. YOLO. 2. RNN. 3. CNN. 4. GAN. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning. If you found this video helpful, don't forget to hit that like button, subscribe for more tech talks, and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.